of the year. Otherwise, you have been pretty busy. This is our first keynote of the year. We're going to get the spider webs out. And so 2025 was an incredible year. It seemed like everything was happening all at the same time, and in fact, it probably was. The first thing, of course, is scaling laws. In 2015, the first language model that I thought was really going to make a difference made a huge difference. It was called BERT. 2017, Transformers came. It wasn't until 5 years later, 2022, that ChatGPT moment happened, and it awakened the world to the possibilities of artificial intelligence. Something very important happened a year after that. The first O1 model from ChatGPT, the first reasoning model, completely revolutionary, invented this idea called test time scaling, which is a very commonsensical thing. Not only do we pre-train a model to learn, we post-train it with our reinforcement learning so that it could learn skills. And now we also have test time scaling, which is another way of saying thinking. You think in real time. Each one of these phases of artificial intelligence requires an enormous amount of compute. And the computing law continued to scale. Large language models continued to get better. Meanwhile, another breakthrough happened. And this breakthrough happened in 2024. Agentic systems started to emerge. In 2025, it started to proliferate just about everywhere. Agentic models that have the ability to reason, look up information, do research, use tools, plan futures, simulate outcomes, all of a sudden started to solve very, very important problems. One of my favorite agentic models is called Cursor, which revolutionized the way we do software programming at NVIDIA. Agentic systems are going to really take off from here. Of course, there were other types of AI. We know that large language models isn't the only type of information. Wherever the universe has information, wherever the universe has structure, we could teach a large language model, a form of language model, to go understand that information, to understand its representation, and to turn that into an AI. One of the biggest, most important one is physical AI. AIs that understand the laws of nature. And then, of course, physical AI is about AIs interacting with the world, but the world itself has information, encoded information, and that's called AI physics. AI that, in the case of physical AI, you have AI that interacts with the physical world, and you have AI physics, AI that understands the laws of physics. And then lastly, one of the most important things that happened last year, the advancement of open models. We can now know that AI is going to proliferate everywhere when open source, when open innovation, when innovation across every single company and every industry around the world is activated at the same time. Open models really took off last year. In fact, last year, we saw the advance of DeepSeek R1, the first open model that's a reasoning system. It caught the world by surprise, and it activated, literally, this entire movement. It's really, really exciting work. We're so happy with it. Now, we have open model systems all over the world of all different kinds, and we now know that open models have also reached the frontier. Still solidly is 6 months behind the frontier models, but every single 6 months, a new model is emerging, and these models are getting smarter and smarter. Because of that, you could see the number of downloads has exploded. The number of downloads is growing so fast because startups want to participate in the AI revolution. Large companies want to, researchers want to, students want to, just about every single country wants to. How is it possible that intelligence, the digital form of intelligence, will leave anyone behind? And so open models has really revolutionized artificial intelligence last year. This entire industry is going to be reshaped as a result of that. Now, we had this inkling some time ago. You might have heard that several years ago, we just started to build and operate our own AI supercomputers. We call them DGX clouds. A lot of people asked, are you going into the cloud business? The answer is no. We're building these DGX supercomputers for our own use. Well, it turns out we have billions of dollars of supercomputers in operation. so that we could develop our open models. I am so pleased with the work that we're doing. It is starting to attract attention all over the world and all over the industries because we are doing frontier AI model work in so many different domains. The work that we did in proteins, in digital biology, La Proteina to be able to synthesize and generate proteins, OpenFold 3 to understand the structure of proteins, Evo2, how to understand and generate multiple proteins, otherwise the beginnings of cellular representation. Earth2 AI that understands laws of physics, the work that we did with ForecastNet, the work that we did with Cordiv, really revolutionized the way that people are doing weather prediction. Nemotron, we've now doing groundbreaking work there. The first hybrid transformer SSM model that's incredibly fast and therefore can think for a very long time.